Hello students. Today we are going to learn something about classless addressing. In previous lectures we have understand the concept of classful addressing. So these are the objective. What is classless addressing? How we can assign addresses, how we can find out the addresses, how many number of addresses are there in a particular block and subnetting in classless addressing with IPv4. So in year 1996 classless addressing is announced just because of the few problems with classful addressing. Suppose let's take a scenario like suppose the shopkeeper is there and a customer came and asked for the 100 kg packet of a rice. So if a shopkeeper gives that particular packet to a person, he will take it, and after that nobody else can use that particular 100 kg of rice, even a small quantity of that rice, without the permission of that particular person, or maybe no one can use it simply, whether that particular person use it, waste it, or anything whatever he wants. But suppose customer came and asked for the 100 kg, and shopkeeper said, tell me the exact minimum quantity which will be feasible for you. So customer said, okay, give me 20 kgs. So 20 kg given to that particular customer, and some other customer came, few have taken 5 kg, someone take 10 kg, and so on. So now you can see the scenario. Number of customers can be satisfied with this particular philosophy, and rice is distributed amongst everyone or many peoples, and wastage is also very less in this case. But in previous case, 100 kg owner is one, and whether he will use it or waste it, that will be a choice of that particular customer. Similar scenario came into the concept of IP address allotment. Suppose in classful addressing, if someone takes the address of 172.16.0.0, now these two octets we know start, and number of addresses will be 0 to 255. Address can be allotted to the client, but no one else can use this particular network address for their own purposes. And we all know near about 65,500 hosts can be allotted in a class B network with all the permutation combination of these two octet for the host. And suppose the organization uses only 2000 addresses or something, 3000, rest becomes waste. So this is the biggest problem with the classful addressing, right? So there's a need of second philosophy which we have discussed with the shopkeeper, that when someone came to internet authorities for the address allotment, then they have to declare how many addresses they require, and internet authorities will provide them a block which consists of that particular number of addresses. They will give the starting address, end address, and total number of addresses, because block consists of what? Starting address, total number of addresses, and last address, right? So these variables, and somebody came and asked some different number of addresses, they will be given and or allotted on the basis of their requirement. And that particular blocks are multiple of power of 2, that you will understand in coming slides. So this is the overall address space, and you can see the block size of addresses which is allotted to a different organizations by the internet authorities are different in size, and size consists of what? Number of addresses. That will be based on users requirement. So these are the restrictions. The number of addresses in a block must be a power of 2, and the first address must be divisible by the number of addresses. Means if a block contains 4 addresses, then the first address must be divisible by 4, the first byte of address, right? And first byte means rightmost. Suppose take an example. Which of the following can be the beginning address of a block that contains 16 addresses? Four options are there, four different IP addresses are written there, and you have to find out the block that contains 16 addresses. Which particular address in this, or maybe addresses, more than one addresses can be the answer. So if you take the restriction like defined in previous slide, the number of addresses can divide the first leftmost byte of the given addresses. So only A and C is divisible by 16, as you can see, right? So A and C will be the answer. Now make it little complicated. Suppose the block contains 256 number of addresses, and these are the following addresses. So which address, which beginning address consists of these 256 addresses? In this case, if you consider it as a, always remember IP version 4 always follows base 256 arithmetic, means everything will be divisible by 256. So in this case, if we divide this particular address and this particular address, then what we will get? 256 as a remainder. Or maybe if you say 0, so you can treat this particular explanation. In this case, the rightmost byte must be 0, right? The total, if first byte is 0, that then definitely total number of addresses is by 256. So B and C will be the answer. Now if block contains 1024 addresses, then what will be the address which this block belongs to? It's a little bit tricky because 256 means 1 octet, 1024 means we have to shift to next octet as well. So you can see the calculation. 1024 is a combination of 4 into 256, right? So the rightmost byte must be divisible by 256, means it should be 0, and the second byte must be divisible by 4 with this number. So this particular C is only fulfilling these two conditions. This is not, because 42 is not divisible by 4. So with these very few examples, you can understand the philosophy of blocks, right? This is not a major thing which we are going to learn, which is coming in next slides. So it's a recap. You know the default classful address masks are this. We can also write this. Now this particular thing is converted in I classless addressing very carefully, and it is also known as CIDR notation. CIDR, classless interdomain routing addressing concept, or classless addressing. In this case, we always write address in this way. Always remember, whenever you see address written in a question paper or somewhere else, or somebody is asking something, first you have to consider whether the given address is IPv version 4 class full addressing or classless addressing, and the only indication is this slash n value, or this prefix length is there with this IP address, then definitely it's a classless addressing IP address. So the n after this defines the number of bits that are same in every address in the block, right? ये भी ये आने वाली स्लाइड्स में आप देखेंगे और इसे समझ जाएंगे कि यहाँ पर क्या कहने की कोशिश की गई है, right? So the two terms are there. Prefix means IP address, the given network ID and everything, and prefix length, which is defined with the help of this slash n. Okay. So now slash n is basically defines mask, which is here known as prefix length, right? but it's the only thing which defines the overall concept of this classless addressing, right? So it's, if we calculate how this particular masking concept is there in this, suppose /1 is the value of n with a particular given address, then mask will be 128.0.0. How? If we consider it in binary, then we can write this particular binary 128 in this manner. Then we know the binary bit positions as 1 2 4 8 16 32 64 and the 128, and we consider only the value of 1 which is at the position 128. So the octet will, first octet will be 128.0.0.0. Suppose the value of /n is 2, then 192.0.0.0 will be the mask. How? Then it means 2 bits are 1 in this 8 bit, then you know this is the position of 128 and second one is 64. So if we add 128 and 64, it becomes 192, right? So the mask will be this. And suppose in the last, if /8 will be the value of n, then you know all ones becomes 1, all ones becomes 255, right? And you can also compare it with default mask of class A if you compare it with classful addressing, right? Suppose /9 is there, then why this address is 255.128.0.0? Because in case of 9, first 8 bits of first octet becomes 1, right? And then first bit becomes 1 and rest will be 0. Okay, so 8 plus 9, these are the 9 bits which are 1. So this becomes 255 dot, and this is the position of 128. So the mask is 255.128.0.0. Okay, similarly all the masks are calculated. This is the default mask of class B, you know, and this is the class C mask. Okay, so these particular calculations are involved in calculating the mask with the help of prefix length given in a classless addressing. Okay, and very soon you will see how this is important. Now the first question, a randomly address is given and you have to find out the first address in the block. You have to find out the first address of a block, and this particular address given here belongs to that particular block. First, obviously it's a classless addressing case and CIDR notation is there, and then we have to find out the first address of a given block. So prefix length is 27, and in first slide you have seen that 27 prefix means first 27 bits will same as network address, right? And the remaining 5 bits, because total address space is 32, becomes 0. So how we will calculate it? Write down the address in binary, then keep the left 27 bits as it is, right? And the remaining 5 becomes 0, and perform AND operation, binary AND operation between these two. Then you will see finally you will get this address when you convert it into decimal. And now you can see these three are same. The random address given in the block from the block was 82 in last octet, and the first address we find it 64, which will be your network address, and rest becomes host addresses. The philosophy of first and broadcast address is same as in classful addressing. Now again, one more method is there through which you can find out the first address of a block if random address from the block is given. So here prefix length is 20. So how we can find it? Now if you see 140.120.84.24 is there, and if we see the prefix length 8, 8 mean all ones, and here 4 is given because 8 8 16 420, and rest becomes 0, so this octet will becomes 0. So in case of first, second and third octet, we don't need to calculate anything because will they will give the similar values. The only difference in this particular third octet means this is fourth, right? And in third octet we have to calculate things. So write down the binary of this third octet value, then make 4 bits as it is and remaining becomes 0, and then perform AND operation. This particular bit will cancel because 0 1 0, and the final calculation will give you in decimal is 80. So this can be a method through which you can also calculate the value of first address in a block, right? So one more method is there which is similar to the previous one, like write down the values of only that particular octet which is different, then leave this portion because there's no need to calculate, and then when you calculate it, this becomes 80 without converting it into binary, right? So now the next question. Now we have seen the three methods how to calculate the first address of a given block. Now find the number of addresses in a given block, right? And the given address is this. So a simple formula is there. You have to find out the numbers, right? So the prefix length is 20, and we know the total address space is of 32 bits. Then 2 to the power 32 minus 20 equal to 2 to the power 12, and when we calculate it, it becomes 4096. So it's a 4096 number of addresses block, which is huge. If you can see, we can allot 4096 addresses from the given block. So these are the few methods through which we can calculate number of addresses, first addresses, the concept of mask in classless addressing, CIDR notation, etc. And the most important part, why we use this classless addressing, just because of to avoid wastage of IP addresses. Although IPv4 wastage and usage everything is over now, very soon we are switching to IPv6, right? So this is all from this particular presentation and lecture. Rest we will discuss in next lecture. Thank you.